A very lovely hello, good evening to all my class 9th champions, to all 9th ninjas. So first of all, I would like to welcome you everyone again on your favorite channel, Deeksha Vedantu CBSE English, and this is your, of course, Sonu Sir. So my dear, before I start this live class of chapter number 4, exploring algebraic identities from your Ganit Manjari, very interesting chapter. You guys, you all are going to fall in love with this chapter. This is my assurance and this is my promise to you all. But for this, you have to watch this live class till the end, everyone. Stay connected with me. So before I start this session, please let me know, champions. You all can hear me. My voice is audible to you and I'm clearly visible to everyone. Yes, everyone. Join fast, everyone. I'm waiting for the response from you all in chat section. Am I audible to you all? Am I visible to you all, everyone? Okay, so join fast. Hello, hi Meena. Hello, Adilakshmi Gopal, sorry. Hi everyone, welcome. Join fast, come on. Join quickly. I have brought up here the interesting chapter, and this chapter might be coming in your exam, very first exam, whether it is PA, that is PT1, yeah. So this chapter might be coming in your exam at your school, everyone. So you all are going to fall in love with this chapter, exploring algebraic identities, because I'm going to teach you this entire chapter in a very quick manner, but from basics to advanced. Yes, my dear, I'll not be jumping direct to any advanced concept. I will be teaching you from basics, champions. So this is going to be game changing for you all. Okay, so let's start. So my dear, the chapter number 4 is exploring algebraic identities from your new NCERT textbook, that is Ganit Manjari. Okay, and let's start. So moving ahead, the first question here is, what do you understand by algebraic identities? So my dear, can you see on screen here? Can you see here? These all are algebraic identities. Yeah, this is the first identity. I will be teaching you everything, but have a look, have a short picture to, what kind of algebraic identities formulas we have. So this is identity toolkit. We'll be discussing about each and everything separately on every respective slide. Don't worry. This is the picture. So this is a plus b whole square, a square plus b square plus 2ab. This is a square plus b square plus 2ab, a plus b whole square. So this is called algebraic identity. Second is a minus b whole square, a square plus b square minus 2ab. Third is a square minus b square. These all are, can you see here, 9 identities are there. And these are most important identities. Sound very low. Okay. Risky Dunya. Oh my God, what a name. Now am I audible to you guys? Now is it clear, everyone? Clearly? I hope now voice is little bit louder. Yeah, Risky Dunya, please tell me. Am I audible to you, everyone, clearly? Okay, so these are algebraic identities, everyone. They all are having some special character, special, identity. So we will be discussing about each and everything on the next slide. Have patience, but look at the picture. These are the, take a screenshot. If you want to write later in your rough notebook or in your fair notebook, please take a screenshot. Moving ahead. Okay, now come to what is an identity. First of all, what do you understand by algebra? What do you understand by algebraic identity? Listen, champion. Algebraic identity. So before moving to algebraic identity, let's talk about first what is called algebra. So this is here. Let's talk about, this is AIC. Let's talk about what do you understand by algebra. My dear champion, algebra means what? Can anyone define algebra? Basically, champion, algebra means when we combine variables, so variables are basically x, y, z and everything. Okay, so x, y, z, etc. They are called variables. Because sometimes when we solve the questions, sometimes x is coming as 2, x is coming as 5, sometimes y is coming as -1. So the values of these things will keep changing. The values of x, y, z are not fixed. So that is why they are called variable. And we have one more thing. This is called constant. What are called constant? The numbers. The mathematical digits are called constant. For example, 3, -2, 7, etc. They are the constant, champions. But when we combine variable and constant in systematic order, the combination of both will give you a systematic format, and that systematic format is called algebraic format. For example, if we take variable x and if we take constant, so we can write 3x plus if we take one more y and equal to 0. Now this is an equation and this is also called algebraic expression. So the systematic combination of, the systematic arrangement of variable and constant will give you algebraic expression, algebra. And some equations are having special character, special identity, and such special identities are called algebraic identities, and these are the algebraic identities. We'll be talking about later on, don't worry. Watch the video. Okay, so I hope this is clear to you all. What is called algebraic expression? The systematic combination of variable and constant. What are called variables? Variables are x, y, z, a, b, c, d, because their values are not fixed. Sometime x will be 5, sometime x will be -3, sometime x will be equal to 0. So their values are not fixed, and that is why they are called variable, and they are called, the numbers are called constant. But when you combine variable and constant, this expression is called algebraic expression. And we have so many types of algebraic expression. You all know this: linear equation, quadratic polynomial, cubic polynomial. So I hope this is clear to you all. So the arrangement. Now moving ahead. Now my dear champion, very important thing that I want to tell you everyone. Most of the students are having confusion. They don't know to differentiate between identity and equation. Let me tell you what is called identity and what is called equation. Listen champion, there is very basic difference between identity and equation. Let me tell you, my dear, if you can see here this equation, first case here, x square minus 1 is equal to 24. Look at this expression, x square minus 1 is equal to 24. Now my dear champion, if we bring this minus 1 that side, so we can write x square is equal to 25. If we pull this minus 1 there, so 24 will become 25. Now after removing a square, it will go in under root. So we are having values of x are plus 5 minus 5. It means that this equation, this expression have only one value, plus 5 and minus 5. It means that this equation has only one solution. Only one solution. So this is called equation. But identities are those equation, those expression. If we put x anything, if we put anything y, the identity will be following RHS side and LHS side. Let me show you. If x plus y whole square is there, we can say that a square plus b square plus 2ab. This is called identity. Why? If you put x anything, if you put y anything, to the right hand side and left side, both will be verifying, both will be equating, coming equal to each other. Yes, RHS and at any value of x and y, any value. Let me show you. Let's put x is equal to 2 and y is equal to 3. Let's put. So x plus 2 will be 5. 2 plus 3 will be 5, and this is 5 square. Now check RHS. So this is 2 square will be 4, y square will be 9, plus 2 into, this is 2 into x and 3. Now solve this. 9 plus 4 will be 13. 2 to the 4, 3 is 12. Oh my God, RHS is 25 and LHS is also 25. Wow. Now, if any one of you, if anyone from you wants to put x as 3, and y as minus 2, put these two values now here. Again, this will be satisfying. So identities are those special expression which will be satisfying all the values of x and y. So this is the difference between equation and identity. Equation x square minus 1 is equal to 24. True only for x is equal to plus minus 5. But if we talk about identity, it is true for all x and y. Can you see here? So identity follows all x and y, but equation has only one value. When you solve the equation, you will be having only one answer. I mean, the answer might be plus minus, but only 5 only is there, no? So there is only one solution, right? But identity will be satisfying at any value of x, at any value of y. This is the difference between. So if I ask you, champion, tell me whether this is equation or identity. So this is x square minus 1 is equal to 8. Tell me, this is equation or identity? Please write in chat section. Please write in chat section. X square minus 1 is equal to 8 is equation or identity? I'm waiting for the response in chat section, everyone. X square minus 1 is equal to 8 is identity or equation? Please tell me. Please tell me. X square minus 1 is equal to 8 is an equation or identity? Tell me. I want to see the name of that student who will give me the correct answer for this question. My question is, x square minus 1 is equal to 8 is an equation or an identity? Write correct answer in chat section. Yes, come on. X square minus 1 is equal to 8 is an identity or equation? Anyone is there? Who is there? Akshara is writing equation. Yes, Akshara. Perfect. Why? Because this equation is satisfying at only one value of x. At only one value of which is equal to plus minus 3. There is no any other value of x which will be satisfying this equation except plus minus 3. When we put here plus 3, so 3 square 9, 9 minus 1 is equal to 8 is equal to 8. When we put minus 3, minus 3 square minus 1, so again this will be 9 minus 1 which is equal to 8. There is no any other value apart from this. So this is equation. When the value of x is satisfying at only one, that is equation. But identity is satisfying at any value of x and y. Okay. So we have question here, equation or identity. So 2x plus 3 is equal to 9. This will be equation because x is satisfying at 3. But a square minus b square is what? This is an identity. Moving ahead. So this is your homework. Take a screenshot, everyone. Hello, sir. Hi. Hi, Shamalk, Sam Hulk. Wow. Hello, everyone. Very good. Very good. So this is your homework. Is 3x minus 1 3 is an equation or identity? Come on, solve this. This is clearly equation because there will be only one solution of x. When you solve this expression, there will be only one solution of x. Hi, Sam. I got your message. Okay, moving ahead. Okay, so the first identity came here in front of you, a square of sum a plus b whole square. So my dear class 9th champion, this is the most frequent used equation in the world of education, I can say, in the world of mathematics, in the world of physics, science, chemistry, whatever. This is the widely used formula. Identity, very important, very important. Okay, so this is an identity. A plus b whole square is equal to a square plus b square plus 2ab. Why I am calling this as an identity? Because if you put a anything, let's a2 and b as 1. If you put a2, b1, both the sides, RHS and LHS, the answer of RHS and the answer of LHS will be equal to each other. Let me show you how. If you put here 2 and 1, 2 plus 1 will be 3, 2 plus 1 square. Now put here 2 square plus 2 into a2, 1b, and this is plus here, plus b square, 1 square. This is 1 square. Now 2 plus 1 is 3, 3 square will be 9. Now solve this. 2 square will be 4, 2 2 ja 4, 1 ja 4, plus 1 square will be 1. Now solve this. Oh my God, can you see here? Can you see here? The RHS and LHS both have become equal to each other. It indicates that this is clearly an identity. Why? If you select anything A, anything B, this will be satisfying RHS and LHS at any value of A, at any value of B. Hi Sanchit, hi. Is it clear, everyone? Now the question came here, sir, how this identity came into existence? Who derived this identity? How we can prove this is correct or not? So let me show you the proof, everyone. So I'm going to show you the proof of this, how you guys can prove it. So my dear, let's prove a plus b whole square identity. So my dear, to prove a plus b whole square identity, we required, listen here, champion, look at the screen. Look at the screen here. So I have taken, this is the screen here, I have taken a square of side A. This is the square of side A. This is A. So this will also be A, right? And this will also will become A, and this is also will be A, right? This is A. Square of side A. Okay. Now, after producing the side A to B, this was earlier, this side was A. Now we have produced this by B. And so this whole side will become A plus B because we have produced A till B. Now this is A plus B and we want A plus B whole square. So A plus B whole square means what? We required a new square, the bigger square, whose area A plus B whole square. So let me give you a short trick. My dear, draw a line. Draw a line. Let me take your line from this. That will be great. This is a line here. Okay. And let's assume this is A and here this is B. This part is B. So this entire line will become A plus B. I hope this is clear to you all. This is A and this is B. So this entire line will become A plus B. Now draw a square of this same side. Draw a square of this same side A plus B. So draw a square. So I need a square here. So one more square. This. I need line here. This and this. Okay. So we have this square of side A plus B. So it has to be, this will be A plus B. This will be A plus B. And this will also be A plus B. Right, everyone? Right, everyone? Now, can you see here? If this is B here, this is B here, champion. So, if this is B and we want to calculate A plus B whole square. So, to find out A plus B whole square, we want area of this square. And now, if this is A, so A is the side here till here. Now draw a square of side A. So this will be A square. Because here this is A. Till here this is A. So this will be A square. Right. Now join this. Join this. And join this. Wow. What will be the logic? Come on. Look at here. My dear, if this is B and this is A, because we have this square, this is A, so A into B will be AB, area of rectangle. And if this is B, this is B, this is B, this is B, so this will be B square, one more square. And if this is A here and this is B, so this is rectangle, so we have AB. Wow. So if you calculate the area of entire square, so area of entire square of bigger square will be equal to what? Area of the sum of these four portions, right? So area of this square, A square, area of this square, B square, area of these two triangles. So this is AB, this is AB, so we can write 2AB. And can you see here, area of bigger circle, the area of bigger square, the bigger square is having side AB. So the area will become A plus B whole square. So we have A plus B whole square is equal to A square plus B square plus 2AB. So this is the way how we can prove the first identity by using geometry, everyone. I hope this is clear to you all. Yes, tell me, my dear champion, is it clear to all, everyone? Yes, everyone, is it clear? Yes. Please write in chat section, yes sir, yeah. Is it clear to all how you guys can prove this? Is it clear to all? If this proof is clear to everyone, please give me thumbs up in chat section. Write yes sir, enjoying, or send me some hearts also, so that I can ensure myself you guys are literally understanding the concept. Please tell me, is it clear? So this is the way, champion, how we can prove that A plus B whole square is equal to A square plus B square plus 2AB. So this is the first identity, everyone. And we have proved by using geometry. Once more. Okay. Someone is asking there, Sam is asking there, sir, once more. So my dear, listen everyone. We want to prove A plus B whole square. Just imagine there is a square of side A plus B. Just imagine if there is a square of side A plus B. So what will be the area of this square? Of course, side is square. So this will be A plus B square. So that is the reason why this entire derivation is moving around the square, because we want A plus B whole square. So what I did here, listen everyone, I'm explaining again. What I did here, I have drawn a line of side A. I have drawn a line of side A, and this A is increased to B. Is it clear everyone? First I have drawn a line of side A, and this A is produced to B. So this entire line will be A plus B, because I am targeting A plus B, the bigger square. Okay. Now, taking side as A, I have drawn a square. I have drawn a square. So the area will be A square. Very good. Okay. If I want A plus B whole square, so I want one more square, the bigger one. So A plus B, this was the A plus B. So I have drawn here one more bigger square. But after drawing this bigger square, we got three more portions. This portion, and this portion. And if this is A, and here this is B, so this will also be B, this will also be B, and if this is A, so this will also be B. So this is a square of side B, so area will be B square. And this portion is the rectangle of length A and breadth B. So this is area AB. This is one more rectangle of length A. This is A and this is B. So the area will be A plus B. So the area of this bigger square will be equal to the sum of area of this plus this plus this plus this. And after doing this, we got the identity. Is it clear everyone? Is it clear? So this is the way how we can prove. So now let's do a question here. So this is your turn. NCERT exercise 4.1. This question is from NCERT. Look at the question. Expand 7x plus 4y whole square. Come on yaar. You can imagine this as A. You can imagine this as B. So this is basically A plus B whole square. So we can use A plus B whole square. And we have formula A square. So this is 7x square plus B square 4y square plus 2 into A into B. Now solve the answer. So 7x square will be 49x square, 4y square will be 16y square, and this is 2ab. So we can write 7 to the 40, 7 4 ja 28, 28 to the 56, 56 yx. This is the answer. Everyone, so this is the answer. We have expanded this format with respect to this a square plus b square plus 2ab. I hope this is clear to all. Very good, everyone. Is it clear to all? Are you guys enjoying the session? So this is the magical way how we can prove a plus b whole square. Moving ahead. Okay, now again same perfect square. So this reverse is also clear. If we can write a plus b whole square as this, so we can also make the reverse format. If the equation is already in this format, so we can factorize and we can write the expanded form into small form. For example, let me show you. Look at the question here. Look at the question. If this is 9x square plus 24xy plus 16y square, right? So this is already given in expanded form. So we can do one thing. 9x square can be written as 3x square. And don't do anything to this initially. Do this. This 16y square can be written as 4y square. Is it clear? Why I have denied you to not disturb anything? First do this. Why? Because these two brackets will be giving you what should we write here. So this is a square. This is b square. So the middle term should be 2ab. So let's write 2 and this will automatically come there. And this will automatically come there. And if you multiply these three, same values will come. 3 2 ja 6, 6 4 ja 24ay, 24xy. Right? So always focus on a square and b square, then 2ab. Now can you see? This is a square, b square plus 2ab. So if the equation is already in expanded form, we can write short form it. Right? So a is 3x and this is 4y. 3x plus 4y whole square. This is the answer. So we can apply a plus b whole square to write this, or we can also go in reverse format. Is it clear, everyone? Yes. Yes, is it clear all? This question is clear to everyone? So reverse is also format. We can say this is reverse of a plus b whole square, and this is called backward to factorize. Reading the identity backward to factorize. I hope this is clear to everyone. And same question again here, 36x square. So 36x square can be written as 6x whole square, right? And don't do anything to middle term. Here is plus 1, so 1 can be written as 1 square. A square plus b square. A square plus b square. Now we require 2ab, so this will automatically become 2a will be 6x and b will be 1. And if you multiply 6 to 12x, come on, same number is coming, same family is coming. So this is a plus b whole square. So we can write 6x plus 1 whole square. This is the answer. I hope this is clear to all. From where are you guys? Oh, you guys are talking with each other. Come on, don't do this. Focus on question. Okay. Now moving ahead, let's talk about the second identity, a minus b whole square. Till now, we were discussing about a plus b whole square. Now, we are going to discuss about a minus b whole square, how we can derive the equation identity of a minus b whole square. Very important for 9th standard. Okay. Now, do one thing. Let's first talk about how to derive this identity using geometry. Using geometry. So let's derive this. Let me show you the derivation. Who is this? Hi everyone. Hi guys. Ashoka. Hi Ashoka Sani. Hi everyone. Welcome to Deeksha CBSE channel. If you haven't subscribed the channel yet, go and hit the subscribe button, and kindly make sure to hit the like button also of this live session. Go and hit the like button, everyone. Okay, moving ahead. So let's derive a minus b whole square, how this equation came, and we will be doing few questions also based on this identity. Okay. So my dear, can you see here? This is a minus b. How we can make a line a minus b, and we want square of that. A minus b whole square. So there is only one procedure how we can get this format a minus b whole square, by using the concept of area of square. You know why? Because when we calculate the area of a square, the area of a square is basically equal to side square, right? So if we do anything and if we make a square of side a minus b, so the area of that square will be equal to a minus b whole square. So that's why we are targeting on square. Are you getting my point, everyone? Is it clear, everyone? That's why we are targeting on square. So let's draw. Let me use white color. Okay. So please focus, everyone, here. So let's draw a square here. I am drawing here. Okay. This is a square. This is a square. Okay. And this entire side, initially it was A. This is A. Oh, this is A, right? And this part is basically B. This is B. The complete side is A. It is not clearly visible. Okay, let me draw the pink line little below. Okay. Okay. And this is B. My dear champion, if complete line is A and this B is the length on that line also, this B, this is the length B. So what will be, if I ask you, what will be this? Oh, wow, this will become A minus B. I hope you all are agree with me. Yes or no? If this entire green line is A and this portion is B, so this will become A minus B. Clear? Clear? Okay. Now, draw the square here of side A minus B. This, I want square. So, yes. No, line should be straight. Line should be straight. So, draw a square here. This, and this, and this. I want square of side A minus B. So, we have a square of side A minus B. Wow. This is A minus B. This is A minus B. This is a minus b, and this is a minus b. Right? Okay. Have patience, have patience. Everything is on the way. Now, my dear champion, do one thing. If this is b, and this is complete a, now draw a complete square of side a. If we increase this here, here, and here, so this side was a, the complete side was a, so it has to be also a. Wow. Right? And it has to be also a. But what will happen to this? This and this. So if this is b and this is a minus b, so the area of this rectangle will be b into a minus b, because we know the area of rectangle is length into breadth. Okay. Now if this is b here, this is b here, so this area will be b square, because we have that square. Now what will be the area? This a minus b, here this is b, and this is here, this is, can you see here, this is a minus b, right? This is a minus b till here, and this entire is a, so it has to be b. This is b, this is b, this is b, this is b, right? So this will be, this area will be b into a minus b. Wow, this is the geometry. I hope this is clear to all, everyone. Please solve. Yeah. Hi. Who is this? Ashoka. Didn't get this square. Okay. I can explain this question again for you, Ashoka. Don't worry, here I'm here. Okay, Ashoka. Okay, listen, everyone, listen. What we want here? We want a minus b whole square. So to get a minus b whole square, we required a square of side a minus b. So initially I have drawn a side of side a. This entire side, this entire is a, and this portion is b. So this will become a minus b. And we want a square of side a minus b. That's why I have drawn a square of side a minus b. This is the square of side a minus b. And we want the area of this. So what will be the area of this square? We all know area of a square is side square. Are you getting my point? Now we all are targeting to find this. We have to find this. So what will be this area? This area, a minus b whole square, will be equal to area of complete square minus area of this plus this plus this. Yes, we want area of this square. So area of this square having side a minus b will be equal to the area of entire square minus sum of these three. So let's do summation. So this will be b square plus this is b into a minus b plus a into a minus b. Now solve this. So this is a minus b whole square. This is a square. Now solve this. B square. Can we please open the bracket? AB and b square minus b square will be minus b square, and this is again a into a square minus ab. Right? A into b, ab minus b square, a square minus. Okay. Now please take all the things. So ab will be cancelled here. So what we are getting here? This is a minus. Okay. This is plus ab. No. A plus b. Okay. Yeah. Simple. So now can you see here? A minus b whole square is equal to a square. And now please open the bracket. Can you see the brackets here? B square and this b square, and this is a square. So what we are getting here, the values have changed. So let's do a little modification here. Small modification we required, and the small modification will be like this. Let me show you the small modification. I can make it very easy solution. What happened here? Okay, sorry guys, a little technical problem. Just a second. Oh my god, where it has gone? Just a second, guys. Some technical problem is there. Just a second. Okay, what happened? Okay, just a second. Okay. Some technical issue is there. Just a second, champion. Let me show you one more method, very easy method. Listen, but due to technical problem, it got erased, everyone. So I need to start from initial, from starting again. Okay, so we want a minus b. Okay, the student who is having little problem, please watch again, because you are the lucky one. Unfortunately, it has erased due to technical problem. So let's start from starting. Okay, so we want a minus b. So do one thing. Let's draw a minus b. This is entire a, and if we take here this portion, this entire is a, and this is b. Okay, so what will be this? This will become a minus b, right? A minus b. Okay, now we want a minus b whole square. So to get a minus b whole square, we need a square of side a minus b. So let's draw a square. This, and this. A minus b. Square is ready. This square is ready. A minus b, a minus b, a minus b. Clear, everyone? Okay. If the entire side is a, so let's make a square. Let's make a square of side a. This will be also a, this will be also a, and this will be also a. But can you see one thing? If this is b here, if this is b, so this will also be b. And this width is symmetry. This width is symmetry everywhere. So this will also be b. And if this is b, so it has to be b also. Because this entire side is a, so this will be a minus b. I hope this is clear to all. Now can you see here, if this is a rectangle, so the area will be b into a minus b. I hope clear. b into a minus b, and this is b square, because that is a square, and the area of this is b, this is b, and this is a, entire a, so a minus b, this is a minus b. So the area of this also will be rectangle, so length into breadth. I hope clear, everyone. Now we want a square of this a minus b whole square. So this we can get from this square, the smaller one, this a minus b whole square. The area of this square is a minus b whole square, because the side is a minus b. So how we can find out the area of this square? If we subtract the sum of these three area from entire square, if we subtract the area sum of these three, the 1, 2, 3 from the entire square, then only we can get the a minus b whole square. So doing that, so a minus b whole square is equal to, this entire is a square minus the sum of these, b square, here is b square plus b into a minus b plus b into a minus, here is, this is, now solve this. So a minus b whole square is equal to a square minus b square. Can we please open the bracket? So ab minus b square plus ab minus b square. Right, everyone? So can we cancel this? This b square will be cancelled, one b square will be cancelled, and this is a minus b whole square is equal to a square minus, now ab plus ab will be 2ab, and this is minus b square plus 2ab. Now can you please open the brackets? So a minus b whole square will be equal to a square, and this minus will be plus b square, and this is plus minus, so this is minus 2ab. Hence proved, a minus b whole square is equal to a square plus b square minus 2ab. I hope now this is clear to everyone. Is it clear to all? Ashok, is it clear to all? Yes, anyone? I hope now Ashok is clear, this is clear to you. And you are lucky one, because technically it was, erased fully, so I have started from beginning. So this is the way how we can prove a minus b whole square. Please let me know in chat section. Yes sir, everything is clear. Thank you so much. Please give me thumbs up in chat section or send me some hearts. Okay, now on this identity we have a question here. Can you see? This is evaluate 29 square mentally. My dear champion, mentally means you don't require pencil or pen to get the answer of this question. Why? Because 29 square can also be written as 30 minus 1 whole square. So this is equal to this. Can you see? Can we make the similarities? 30 minus 1. So 30 is we can consider as A, and B we can consider as 1. So A minus B whole square. So 30 square, that is 900, plus 1 square, B square 1, minus 2AB, it means minus 60. So this is 901 minus 60. You can calculate even in mind. So 901 minus 60 will be what? 1, 4, and this is 8. 841 is the correct answer. This is the answer. Now your turn. This is not visible. So this question is 79 square. Find out the value of 79 square. My dear, 79 square can be written as 80 minus 1 whole square. Now this is A and this is B. This is A minus B whole square. 80 square is 6400 minus 1 square. We can solve. Hi Sanjana, welcome to Deeksha Vedantu champion. Hi Sanjana. I hope this is clear. My dear champion, if I ask you, find out the value of x 101 square, 101 square. My dear champion, you can also write this function as 100 plus 1 whole square, because 101 is equal to 100 plus 1. By modifying this format in this way, now A is 100, B is 1, so we can apply A plus B whole square. Now if I ask you, what will be 999 square? Now my dear, 99 can be written as 100 minus 1 whole square. Now you are free to apply this formula, A minus B whole square, and 100 square will be 1000, then minus doing basic calculation. So you don't require to do long mathematical calculation. You can directly apply algebraic identity. So this is the beauty of algebraic identity. Is it clear to all? Hi sir. Is it clear everyone? I hope this is clear to you all. Moving ahead. Okay. Now coming to a square of trinomial. Trinomial means when three terms are in addition form and we are squaring that. For example, if I ask you 2x plus y plus 3z whole square. So such equations, such expression are called trinomial, because how many terms are there? First term, second term and third term. So there are three terms are adding and then squaring. So this is called square of trinomials, because three terms are in addition form. So my dear, the square of a plus b plus c whole square is equal to a square plus b square plus c square plus 2ab plus 2bc plus 2ca. Very important identity. Very, very important identity, my dear champion. You don't need to negotiate with this identity. You can't compromise this. This is very powerful. Very powerful identity. A square plus b square plus c square is equal to a plus b plus c whole square is equal to a square plus b square plus 2ab plus 2bc plus 2ca. You might be thinking, sir, how should I trust you? Or what is the reason behind it so that we can trust on this equation? How? So let's prove it. This is absolutely fine. Let's select any number as 1, A, B as anything, that's 2, and C as, let's say, 0. Let's say A1, B2 and C0. Now put ABC right hand side and left hand side and verify the values are, verify whether you are getting the equal result or not. So A is 1. You can take anything. If you want to change the number, you can change. But put these three numbers here at the right hand side and the left hand side. So let's solve. I'm putting at right hand side here in this. So this is a square, so 1 square plus b square. B means 2 square plus this is 0, c square. Now 2ab, 2 into a is 1 and b is 2 plus 2 into b into c is already 0, so this will become 0. And here also c present, so when we multiply 2a into c, that will be 0. Now solve this. So 1 square will be 1, 2 square will be 4 plus 2 to the 4 again. Yeah, we are getting 9. So we have 9 at RHS. Now let's put at LHS. So LHS is equal to a plus b plus c whole square, right? So put here a is 1 plus 2 plus 0 whole square. My dear, 1 plus 2 plus 0 will be 3. So 3 whole square. Oh, wow. RHS is also giving 9. 9. LHS is also 9. Hence, prove that this identity is absolutely correct. This identity is powerful. When we have put A1, B2 and C0 at right hand side and left hand side, we are getting same result. We are getting same result. It indicates that this identity is absolutely powerful. Now the question came here, sir, how it proved? How we can prove this identity? So let me give you the proof of this identity, champions. So I hope this is clear to all. Now to prove this identity, let's please look at the screen, champions, everyone. So we have drawn a line here. We have drawn a line here. This is A. The length of this part is B. And the length of this part is C. Because this is A plus B plus C whole square. This is whole square. And whole square indicates that we want a square. And if we calculate the area of a square, then only we can get this expression. Because we all know the area of a square is equal to side square. So to get this expression, we required a square of side A plus B plus C. Then only the area of a square we can write in this format. So that's why we have drawn a square of side A plus B plus C. So this will also be A, and this will be B, and this will be C. A, B and C. Here also this is A, this is B and this is C. Here also A, B and C. Is it clear, everyone? So the area of this entire square will become A plus B plus C whole square. Now at this corner, if this is A and this is also A, so it has become a square. It has become a square. And we all know the area of a square is equal to A square. So this is A square. And now if this is B, so we have, now if this is B and this is already A, because this line is the part of this square. So length into breadth, the area will be AB. And if this is A, so this is also A, and we have already this at C, so the area will be AC. Clear, everyone? Again. Now my dear, if this part is B and this part is A, so this area will be AB. And now again, if this part is A, because this is a square, na? A, and this part is C, so the area will become AC. Similarly, here, if this part is C, because this is C, so this will be also C. And this part is B, so the area will be BC. Now the interesting part is about to come. This is B, this is also B, because this is B. So this is a square of side B, hence the area will be B square. Now, if this is B, and we have this at C, so area will be BC. And can you see here, if this is C, so it has become a square. And if it has become a square, the area will be C square. Wow. Can you see the geometry of this diagram? So my dear champion, if you calculate here the area of entire square, the area of the biggest square, entire square, the area of entire square, let me show you. Area of entire square. What is the side of entire square? A plus B plus C. So the area will be A plus B plus C whole square, because the area of a square is equal to side square. Now this area will be equal to sum of all these portion. This plus 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 this. So let's add A square plus AB plus AC, now plus again AB, now B square, now plus BC plus AC plus BC plus C square. Now to make this expression little attractive and beauty, to maintain the decorum, so let's do one thing. Take a square format all together. A square plus B square plus C square Now, can you see here? This is AB and one more AB we have. So AB plus AB will become 2AB. Plus we have BC here and we have BC here. So this will become 2BC. Again, we have AC here. We can say CA also. And this is AC. So this will become CA. Now let's match here. A square plus B square plus C square plus 2AB. Hence proved. This is the magic champion to prove A plus B plus C whole square. Hi Jayu. Jayush Praveen Rajput. Yeah, very less. I know less number of people are here, but still not matter. Even 3 students are watching the session, 5 students, 10 students enough for me, because if anyone is become topper in future, that is a big achievement for a teacher. And the day is very near when on this channel there will be lack of student watching on live very soon, everyone, because we all are in the unsaturated state. And see, my dear, this channel is dedicatedly designed for the 9th and 10th standard. We have proved in previous session, we have produced a lot of topper. I mean, a lot of students came in 90 plus club. They scored 95, 99 in maths. So I'm not wasting the time here randomly picking the question and all. No more. Whatever I'm teaching you is very relevant content for your exam preparation, for your class test, for your final exam. Very important thing. Hi, what is your name, sir? No limit. I don't say this, champion. It really demoralizing me. Don't do this. My name is Sonu. You can say Sonu Sir. This is your Sonu Sir, your maths teacher. Okay, yeah. Who is this? Levi. Levi, you are talking about arithmetic progression. Yesterday, I taught arithmetic progression in live session, champion. If you want to go, if you want to get quality questions, competency based question, go and watch that live class. Okay, so that will be very important and very beneficial for you, every class 10 champion. Okay. Yeah, hi everyone. Again, hello to all. Is it clear to all how to prove, how to derive A plus B plus C whole square? So to find out A plus B plus C whole square, we required a square of side A plus B plus C. So I have made a square of side A plus B plus C. This is the entire square. And this, the area of this entire square will be equal to sum of these 9 portions. So doing the basic maths, we can get the answer. Okay. So based on this identity, we have one question. Find out 119 square. So my dear champion, 119 can also be written as 100 plus 10 plus 9 whole square. And now we can consider 100 as A, 10 as B, and 9 as C. Now we have A plus B whole square. By doing basic maths, we can find out. And now one more homework for you, everyone. Look at the homework. This is homework. You have to expand P plus 3Q plus 7R. My dear, do one thing. You can assume, imagine P as A, 3Q as B, and 7R as C. And you have expansion A square plus B square plus C square plus 2AB plus 2BC plus 2CA. Right, so this is the question here. Moving ahead. Wow. Now, let's talk about A square minus B square. The next identity is difference of 2 squares. Difference of 2 square. I mean, for example, if I'm writing here 7x square minus 9y square like this. So how we can expand this? So this is A square minus B square. A square minus B square. So that's why this is called difference of 2 squares. Difference means subtraction, and these two, both families are in a square form. So this is difference of square. Okay. So we have A square minus B square is equal to A plus B into A minus B. Now you might be thinking, sir, how it derived? How we can derive A square minus B square? So please keep this identity in mind. Very important identity. A square minus B square, we can write A plus B, A minus B. Let me show you how. My dear, just look at this question here. The question is find 102 into 98. So 102 we can write 100 plus 2. And 98 can be written as 100 minus 2. The condition is that, everyone, if this is B, so it should also be B. If this is A, it should also be A. So can you see 100 and 100 same? And after plus, after minus, digits are also same. So now we can apply this identity. So if A square minus B square can be written as this, right? So it can also be written as this. The reverse is also possible. The backward is also possible. So we can write here 100 square 100 square minus 2 square. Because a plus b into a minus b, it can be written as a square minus b square. So 100 square will be, so whenever 100 square is there, my dear, so 2 zeros are already there. So if you multiply, a square is there, it means that you have to put 2 more zeros. If 3 power 3 is there, you have to put 6 more 6 zeros. It should be 6 zeros. And here if a square is there, so there should be 4 zeros. So there are 4 zeros on 100. And now 2 square will be 4. So 10,000 minus 100 will be 9,996. This will be the answer. I hope this is clear to all. Hi, clear sir. Akshara. Very good. Is it clear everyone? Is it clear? So this is very important, my dear. You can write, if the expression is already in this format, so you can write this way. If the expression is in this format, you can write this. So you are free to apply whether you want to go from here to here or from here to here. You are free to apply both. So my dear, I'm giving you one question. Can you see this question here? Find the product of this. Some student, what will they will be doing there? They will be multiplying from this 2s to this whole bracket, then 7 to this whole bracket, and it will be utilizing lot of time. Don't do this, because you can see here, this is similar to a plus b and this is a minus b, right? Because at the place of a, this is 2s, this is 2s. At the place of b, this is 7, this is 7. So this is clearly a plus b, a minus b. So if a plus b, a minus b identity is there, so we can write a square minus b square. Reverse gear. So this will become 2s square minus 7 square. So what will be the result? 2s square will be 4s square and 7 square is 49. This is the answer. So just in 3 to 5 seconds, 10 seconds, you all can get the correct answer. Is it clear everyone? If this is clear, hi Akshara, yeah, very good. If this is clear to everyone, give me thumbs up, send me some hearts, show me your presence. Come on yaar, show me your presence. As you all are enjoying the session, you are literally enjoying the session, because I am teaching you from basics. Very important session this is. And I will be coming out with the part 2 also of this, because we cannot complete this entire chapter in one live session. So I will be coming out with one more live class for this chapter, exploring algebraic identities, because in this chapter there are a lot of concepts, lot of identities are there. So this is very important. A square minus b square is a plus b, a minus b. I hope this question is clear to you all. If this question is clear to everyone, this question, please give me thumbs up. Okay, now the question is how it derived. This is the big question. So how to derive? So this is very easy. Let me show you the derivation of this. Listen, champion. Please look at the screen. Can you see here? This is a square. This is a square. So do one thing. To get a square, draw a square of side A. Come on here. Draw a square of side A. So let's draw. This is the square. This is the square of side A. A. Okay. Perfect. Now this is b square. A square minus b square. So we are subtracting the area of square of side B from the area of square of side A. That is the scenario. So we have already drawn square of side A. Now we required one more square having side B. So what we need to do? No, one more thing. B is subtracting from A. So the square of side B will be inside the A. Right. So let's draw here. Somewhere, let's say I'm drawing here B. This is B. B, and this will also be B. This will also be B. I hope this is clear to everyone. So we have drawn first A. This entire is A. This entire is A. But we want A square minus B square. So the smaller square must be inside A. So now we can find out. So what will be A square? A square minus B square. The area of this minus this. This will be equal to this. This will be. So we have to consider 1 plus 2 plus 3. Right? The area of this square minus this square. This is B square, champion. This is B square. Right? So A square minus B square will be equal to 1 plus 2 plus 3. Now, where is 1? 1, this is 1. This is 1. And if this is B, 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 this is B, this is also B. Can you see? This is also B. So this will be A minus B. Wow. This will be A minus B. Alright? This will be A minus B. And one more thing. If this is B, so what will be the scenario? Listen here. Listen here. So we can directly write here. If this is B, this is B, this is B, and this is A. So this will be A minus B. And if this is again B, so this will be A minus B. Right? And if this is B, so this will be B. So this will also be A minus B. Right, everyone? Now solve this. So what will be the scene? The scene will be, and this also will be A minus B. A minus B, A minus B, and this is B. So the area will be B into A minus B. Right? Plus this is B, and this will be A minus B. This is B, this is A minus B. So this will be A minus B. Right? Plus, what is the scene? Again, this we have. So this is B into A minus B. B into A minus B. Can we take B common here? So on taking B common, we have A minus B plus A minus B. Sorry, I want space here. A minus B plus A minus B. Right, now we can cancel here. Minus B, this is B into 3A minus 3B. So it has become little complex. Let me give you a short method. I need space here. I need little space here, so I need to erase this. I don't have space here, my dear. I hope this is clear to you. Now, moving ahead. Look, we want A square. This is the entire A square. This diagram will be helping to you. Listen, champion. We have this A. So the entire area will be A square. And this is B square. So this will be minus B square. And this will be equal to what? This is the important thing. This is the important thing. A square minus B square. We are subtracting this B square from this entire. And we have, if I draw a line here, so what will be this area? Can you see here? This area. And what will be this area? What will be this area? If this is B here, and if this is A here, right? And if this is B here, so this will be here, this is B, because this is B square, so this will be A minus B. Right? And here, if this is B, so this will also be B. And what is this? What is this? Can you see here? This is A minus B. So when you multiply B into A minus B, right, and this is here, A into A minus B. So we can take A minus B common. So if we take A minus B common, A square minus B square will be equal to A plus B into A minus B, hence proved. This is the way how we can prove A square minus B square. Clear, everyone? Moving ahead. Okay. Now the next identity is product. So my dear, product of x plus a x plus b, this is very magical derivation. So I'll be teaching you in the next live class. So my dear, in part 2, in the next live session, we will be discussing the remaining identity of this chapter. So my dear champion, stay connected with this channel and don't forget to join second part 2 live class of this chapter, because still we have a lot of things to discuss in this chapter, everyone. So I have taught you here in this today's live session first identity, second identity, third identity, fourth identity, fifth identity, and the basic, the concept of algebraic identity. So a lot of things we have discussed here in this session. Don't forget to join the second part 2 live session of this chapter, everyone. Thank you so much for having me. Stay blessed, take care, stay confident, and take care of your parents also. Bye bye, everyone.